Week 10. For 50 kilometers SMF at 1550 nanometers, G sub R equals 1 times 10 to the negative 13 power m, W, G sub SPS equals 5 times 10 to the negative 11 power m, W. Alpha equals 0.2 decibels per kilometer and S sub AF of F equals 50 normal mu m squared. Calculate the threshold power for stimulated Brillouin scattering for 80 km fiber link operating at the following wavelengths. Assume that a sub AF of F equals 50 normal mu m squared and G sub B equals 5 times 10 to the negative 11 power m, W at both wavelengths. 1.3 micrometers and having a loss of 0.5 decibels per kilometer. 1.55 micrometers and having a loss of 0.2 decibels per kilometer. Choose the correct option regarding SBS threshold. Use the data given below for questions 7 and 8. A coupler is to be constructed from two fibers by fusing. Given the coupling coefficient kappa equals 2 meters to the negative 1 power, what is the minimum coupling length required for? Coupling ratio of 50:50. Coupling ratio of 75:25. Which one of the below component can be used as AWD and the multiplexer to extract a single channel? A combination of which of the following components can be used as an add-drop multiplexer? The technique by which variable optical attenuator work is? Use the data given below for questions 12 and 13. A product sheet for 2x2 single-mode biconical tapered coupler with a 406/0 splitting ratio states that the insertion losses are 2.7 decibels for the 60% channel and 4.7 decibels for the 40% channel. If the input power P sub 0 equals 200 normal mu W, find the output levels P sub 1 and P sub 2. Find the excess loss of the coupler. See the figure given below for questions 14, solar. In figure I, 4 optical elements are labeled. From the options below, name these elements correctly. Which of the given options represent the block diagram of a polarization insensitive isolator? Which optical element in figure I would you replace if you want to make it a circulator? Use the data given below for questions 17 and 18. Consider two periodic filters, one with period f sub 1 and the other with period f sub 2, both assumed to be integers. In other words, the first filter selects frequencies f equals mf sub 1, where m is an integer, and the second filter selects wavelengths f equals mf sub 2. If the two filters are cascaded, the resulting filtering function is periodic, with a period given by. If periods of the two filters are 500 GHz and 600 GHz, then the cascaded structure will be periodic with a period of. Use the data given below for questions 19 and 20. Optical power launched into a 10 km single-mode fiber through a 2x2 fiber coupler is P sub I equals 1 mW as shown in the following figure. The fiber coupler has 10 dB power coupling ratio, alpha equals 0.1 or usually referred to as 10 divided by 90 coupler, has no excess loss. The refractive index of the fiber core is N equals 1.5. The fiber pigtail at port C is AR coated, R sub 1 equals 0, and the far end of the 10 km fiber is open in the air, cleave perpendicular to the fiber axis. The isolators assure only unidirectional transmission and their losses are negligible. Neglecting all fiber losses, what is the output optical power P sub O? If the attenuation coefficient of the 10 km fiber is 0.25 decibels per kilometer and neglect losses of other fibers, what is the output optical power P sub O?